Hello all. Welcome to free webinar series organized by Mission Cordoba of Muslim Majlis of University of Sri Jayawardenepura. As scheduled, today we will be having the past paper explanation session for the brothers and sisters who will be sitting for the A-level examination in English Medium Combined Mathematics stream. So, this warm welcome is for Abdul Hakim, graduate of University of Sri Jayawardenepura, to continue the program.
So, as we said, we'll be doing the past paper expression today for 2016 second part. So, I hope you all are okay with this. So today, like last time we did the first part and we did a different setup. So, and because some of you said the video and the audio was a small problem, so I'll be changing a setup a little bit. So, and if you have any questions, you can put it in the chat. But I prefer if you can unmute yourself and ask as well, because that will be more interactive and easy for me as well. Okay, so like, how do you like when you get the exam paper? You go to the exam, you start paper, so you get the whole paper. So how do you approach this paper? First part is there, second part is there. There are different ways you can approach, right? So can any of you tell like how you approach the paper? Like, do you do the first part first, then time it as well, and then do the second part next, or you start with the second part, or you have different approaches? If anyone can tell what they do. Oh, guys, I like if you unmute and speak because it will be a bit more easier and more interactive. Right, sorry. So, like yesterday, I was speaking with one of my friends, like who like really did well in A levels and like will do maths. So his approach, what he said was, okay, someone has said, I'll go with the order. Good. So what he said was, what he did was he usually started with the second part, because he said like the first part has all the questions together gives 250 marks, right? But if you take the second part, one whole question gives you 150 marks. So he said he prioritized the second part. So what he'll do is he'll start with the second part, he'll do a question, and then go back to the first part and answer a few, and then he move on once again to the second part and continue on like that. So that was his approach. Now you can do you have different approaches because it depends on you, right? So there's no one correct approach. You can just you can experiment and do what you want. So for example, what I did personally was I used to set a time for like start with the first part and then set a time for like 20 to 30 minutes. And even if I'm not completed with the first part, like when it's 20, 30 minutes, I move on to the second part. So that's what I did. And another thing on timing. So I think when it comes to A levels, timing is very important because when you mess up on timing, that's when you like mostly mess up on the paper. So like when we take the second part, most people say like 20 allocate like 25 minutes for, like you can't take 1 whole hour for the first part. That's like a bit too much, but it's okay. And for the second part, most people say like what 25 minutes for each question. But don't say 25 minutes times like we have 5 questions, it will take 2 hours. You can say like that, but sometimes you take more time for 1 hour and one question and you'll mess up. So try to time the question, maybe like 20 minutes or something when you do it. So, and another thing like I learned from him was like now when you're in an exam, it's difficult time, right? You can't keep a stopwatch or you got a phone or nothing. You can like time or something and say this is the amount of time I'm taking for this, right? So one thing I learned from him was what he did was like when you're in the exam, you have a clock or a watch, so you can know the time right now, right? So when you're starting the question, say for example, you're starting with the 11th question, you write down the time. What is the time right now? So okay, like now it's 9 something. Yeah, 9:10. So you just write down on the paper itself 9:10. So now you know like if it's 20 minutes, what's the 20-minute limit? 9:30, right? So just you write it down, then you got a feeling. Okay, by 9:30 or 9:35, I need to finish the first finish this question. So like that, keep the timing in your mind and do the paper, because if you like if the timing messed up, like you get a lot of stress. If you take lots of time for one question, then the next part would be much more difficult. So those are some like few points I want to say before like starting the question itself. Right. Okay. So we did the first part last like the last session. So today we'll be doing the second part. Okay. So now how do you select the questions? Now, first of all, yeah, if you can answer, I'd be very happy. Others, I'll be just talking to myself. So how do you select? As one person said, they'll be going in order. Any other question? Any other ways? Easiest one first. Yeah, that's also another way. So what I think is, like, first of all, don't just jump into the question. First, read the whole paper. Don't read the whole, like, read sentence by sentence, but just skim through the whole thing and find what is easier. Like, some people tried the hardest one, but I'd say easier for me, easiest one. So select what's easiest for you, what's comfortable for you, and start with that. Remember, you have only to answer 5 questions. So remember the time and then do it. And you don't have to do it in order. Don't have started 1, 2, 3. It's okay. You can start with 17, move on to 11. Nobody cares. So, like, uh, if you if you want, you can do that. But I'd say go through the whole paper first, and then select what's easiest for you, and then start with that. So for this session, I'll be doing in order, so it'll be easy for you to understand. Right. Let's go with the 11th question. I guess ready. Do you have any questions? You can ask. So I hope you can all see the question. A, B, C are real numbers, such that A plus B plus C is not equal to 0, and A is not equal to 0. Fx is this. We need to show that 1 is not a root of the equation Fx equals 0. So that's the first part. So how do you show if something is a root or a solution of a problem? You can unmute and say, or you can put in the chat. Like, if you unmute, you can say, yeah, substitute it in Fx. So why do we? What's the theorem behind this? So yes, you probably can remember, there's a theorem called remainder theorem, right? So what remainder theorem says is, if you divide, I can't see my screen. So you can see, is this clear for you? I'll be doing it on this for today. It's clear. So what does remainder theorem say? If you have an equation Fx and you divide this whole thing by x, say x minus a, the remainder will be, the remainder is f a, right? We substitute a. But if this f x minus a is a factor of fx, then fa will be 0. That is when the x minus a is a factor. Or another way you can say is that a is a root of fx. So that's what we are going to apply here. So the question was, show that 1 is not a root of the equation fx equals 0. What is fx? Fx is equal to ax squared plus bx plus c. So let's substitute 1 when x is equal to 1. So f1 is equal to x, we can say as 1. So it's a plus b plus c. And they have given that a plus b plus c is not equal to 0. Therefore, we can say 1 is not a root of fx. So that's the first part. Pretty simple, right? Okay, we did the first part. So show that 1 is not a root. So the next thing is, this says a, alpha and beta are the roots of fx equals 0. So we need to show that alpha minus 1 into beta minus 1 is equal to this. Another quadratic equation. So first part is show that alpha into this is this. So how do you do that? If you have fx equals ax squared plus bx plus c is equal to 0, and the roots are given as alpha and beta, what we know is alpha plus beta is equal to minus b over a, and alpha beta is equal to c over a. How did you get that? If you remember, you can, if you take a out, you get x squared plus b over a times x plus c over a is equal to 0. this same thing can be written as x square plus alpha plus beta times x plus c is equal to 0. Sorry, minus. So then what would happen here? If you compare the coefficients, alpha plus beta is equal to minus b over a, and this is alpha beta. Sorry, alpha beta is equal to c over a. So using these two things, we can get the equation that we need. So they're asking alpha minus 1 times beta minus 1 is equal to this. Right? So alpha minus 1 times beta minus 1. So if we simplify this, alpha times beta is alpha beta. Alpha into minus 1 is minus alpha. Minus alpha into minus 1 into beta is minus beta. That is minus. If you take minus out, it will be alpha plus beta. Minus into minus is plus 1. 1 times 1 is 1. So we know alpha beta, we know alpha plus beta. So it just we need to substitute. Alpha beta is C over A. Alpha is minus B over A plus 1. Look at the answer as well before this, because simplifying. So we need, so it's 1 over A times A plus B plus C. So what do we need to do? 1 over A, you can take A out, right? So minus into minus becomes plus. This is C plus B plus 1. If you take 1 over A out, what remains here? C minus minus becomes plus. What remains here? B. If you take A out, it will be A, because A multiplied by A is 1. So that to get the answer in the format A plus B plus C. This is the answer we need. Right? And then they're asking, if you have any questions, just interrupt or interrupt. Okay. So if you have, so then the next question is that the quadratic equation they have given with the roots a alpha 1 over alpha minus 1 and 1 over beta minus 1 as is the roots of gx equals 0, and gx is this. How do we show that? Any ideas? Me doing the questions, like I think it will be better if you can also think and answer, because then it will be easy for you to remember stuff. Okay, so we go back. So what is the equation where the roots are alpha and beta are x in minus alpha x minus beta is equal to x squared. So the roots of this are alpha and beta. Okay, so this can be written as x squared minus alpha plus beta times x plus the addition multiplication alpha beta. Now the same way we are given the two equations of this 1 over alpha minus 1 and 1 over beta minus 1 are the two roots. So we need to find the equation is equal to this, right? So what do we know? It's the same thing. Now instead of alpha, let's call it this new root as alpha 1. Okay. So alpha 1 is 1 over alpha minus 1, right? So let's call the next root as beta 1. That is 1 over beta minus 1. So what do we need is the addition of this. Okay. So in the previous one we got alpha plus beta and alpha beta. So we need the addition of this and the multiplication of these two. Aslim,
Yes, Rana?
can you see the screen?
Yeah, I can see the screen.
Sorry for that. Bit of
Okay,
technical
it's
issue.
okay.
So let's move on. So what we need to find the equation where alpha 1 and beta 1 are the roots of this roots So let's take alpha 1 is 1 minus this thing. 1 over beta minus 1 is beta 1. So what we need is now x squared plus alpha plus beta alpha beta. This is the normal format of this an equation whose roots are alpha and beta. So we need the addition of these two and we need the multiplication of these two. So that's what we need. So we need alpha 1 plus beta 1 and alpha 1 times beta 1. So let's simplify. What's alpha 1 plus beta 1? 1 over alpha minus 1 plus 1 over beta minus 1. So when you add these two, take the common factor alpha minus 1, beta minus 1, multiply beta minus 1 plus alpha minus 1. Now, we need, what do we know? We know alpha times beta and we know alpha plus beta. So we need to make it in such a format so we can substitute. What do we know? Alpha plus beta is minus b over a and alpha beta is c over a. That's what we need to do. So if we simplify this, alpha beta, right? So we can take that out. Alpha plus beta minus 1 plus minus 1 is minus 2. Okay. And this alpha times beta is alpha beta. Alpha times minus 1 is minus alpha. Beta times minus 1 is minus beta. If you take minus out, you can get alpha plus beta. So we are trying to write this in terms of alpha plus beta and alpha beta because that's what we need, right? Minus into minus is plus 1. So we can then substitute what we need. Alpha plus beta is minus b over a, alpha beta is c over a. So let's do that. So this is equal to what is alpha plus beta minus b over a plus minus 2 divided by what is alpha beta c over a minus what is alpha minus beta minus b over a plus 1. Now always when you're simplifying, sort of look at the answer as well, what we need to get. So it's a plus b plus c. You can see there's a plus b plus c and all that stuff. So remember look at the answers as well before getting. Now when you simplify this, so we can take a as the common factor denominator here. So minus b multiply this minus 2a. Minus 2a, the whole thing you divide by a, the denominator. Divide the whole thing by. Now it's c over a, minus minus becomes plus. Now if you take a as the common denominator again, get c, minus minus becomes plus b. If you take a out, it will be plus a, and you divide the whole thing by a. So a and a you can cancel off. So this is sort of the final answer you get. Minus, you can take minus outside, 2a plus b, or just to make it simple, as you said, a plus b plus c is there, so you can say a plus b plus c. So what is this? Alpha 1 plus beta 1, right? No questions, right? Just unmute and ask, no problem. So the next thing we need is alpha 1 beta 1. That is the multiplication. What is alpha 1? 1 over alpha minus 1 multiplied by what is beta 1? 1 over beta minus 1. So similar to what we did before. Now 1 is 1 itself on top. Alpha minus 1 into beta minus 1. We did this before as well. Alpha into beta, alpha beta, alpha into minus 1 minus alpha, beta into minus 1 minus beta. If you take the minus 1 out, it's minus alpha plus beta, minus into minus plus, 1 into 1, 1. Substitute what we need. 1 over alpha beta we know is c over a, minus alpha plus beta is minus b over a plus 1. If you take the whole thing out, you get 1 over c minus minus plus b plus, if we take a out, a. Divide the whole thing by a. Because this is divided by a, we can take the a up, that is the reciprocal. So a over a plus b plus c. What do we need? We need the equation in which alpha 1 and beta 1 are the roots. That means we wrote this before. The equation is x minus alpha 1, sorry, yeah, x minus beta 1. This is what we need, right? And when we simplify this, we know it will come as alpha plus beta times x, sorry, square plus alpha beta, alpha 1, beta 1, alpha 1. Equals it. Now we know alpha plus beta, which we just found out, was, what was it? Minus 2a minus 2a plus b over a plus b plus c times x plus what is alpha beta, a over a plus b plus c is equal to 0. Right? So we simplify it. Before we simplify, look at the answer. What is the answer we need? It's in the format of gx equals a plus b plus c times x square plus 2a plus b x plus a. So if you look at the answer, it's very similar. So if you take the a plus b, multiply the whole thing by a plus b plus c, and this is minus becomes plus. So we'll get the exact answer we need. So x squared. So multiply the whole thing by a plus b plus c. So it's a plus b plus c times x squared is equal plus, y is a minus into minus becomes plus, y is a plus b times x plus a is equal to 0. This is the answer. Gx is equal to this. Any questions? Okay, let's move on to the next part then. So we are given that a is greater than to b and a plus b plus c is greater than 0. Then we show that the minimum value of fx is this. M1 is equal to this, where delta is equal to b square minus 4ac. That's the first thing. And then we need to find the minimum of gx. Okay. So how do you find the minimum value of a function? Any idea? If we have fx equals ax squared plus bx plus c, that format, that's what we have been given. We need to find the minimum value of fx. How do we find that? Reason I'm asking question is like, I just don't want to give you the answer, but I want you to get to the answer. In maths, it's just not about the answer, right? It's about how you get to the answer. You need to make sure your thinking process is correct. So if someone asks for the minimum or the maximum value of a quadratic equation, what steps can you follow to get that? Okay. So what we need to do is we need to find a way in which we can get the minimum value. Now, okay, take the discriminant. Can you explain more about taking the discriminant? Like, so one person has said taking the discriminant. That's good. That's part of the answer. But exactly how? You can unmute and say because it takes a bit time. Take the discriminant and make it equal to 0. That's, well, what we do, why usually when we take the discriminant, what we do is this. We when it's greater than to 0, we can say that there are real roots to the equation. If it's less than to 0, we can say that if the roots are not real. So, but we can't say take the minimum or the maximum value of the function. So for that, what we need to do is we need to take the function or make the function in such a way that we can get the minimum. So the easiest way to do is complete the square. Okay. So thanks for the answer, right? So I'll show you. It will be easier to explain. Now, we are fx is given as a square plus bx plus c is equal to 0. Now we need to make it in such a way that we need to get the minimum or the maximum value. So you take a out, okay? Because we are trying to complete the square, so it's easy if x has no coefficient. X squared plus b over a times x plus c is c over a is equal to 0. Okay, we need to complete the square. Now, how do we complete the square? I'll tell you why we are completing the square in a minute. You take the squared value, where s x, and then you take the x and the coefficient of x and take half of that value. So what is the half of b over a? B over 2a. You square it. Now when you square it, you get two terms. X squared will give you this term, and then like x into this into twice would give you the middle term. But there will also be an extra term, that is the square of this b over 2a. That is b squared over 4a will be 4a squared will be an extra. So we need to subtract that. So c over a minus b over b squared over 4a squared. B squared is b squared, 2a squared is 4a squared, right? So I'll simplify it a bit more. A x plus b over a, b over 2a squared plus 4a squared. If you take as common, then I'll take minus as well. So it will be b squared minus, this is 4, to be make this 4a squared multiplied by 4a. So c multiplied by 4 is 4ac, right? I took the minus out. Okay. Now, why do I say we need to do this to get the minimum value? Now, this is what you see this uh, the the square term here. Now, if the square term is to make fx, so fx minimum comes at what point? So what should the square term x plus b over a 2a, the square term, what is the value of the square term when this whole equation is in the minimum, is at its minimum? Any idea? Zero. Exactly. So why 0? Because if it's square, anything, any value that you put inside, in the value you put inside this becomes positive, right? If it's a negative value, -5, say you square it, it will be +5, +25. And we also know that a is greater than 0, right? It's given that a is greater than 0. That means anything that you put inside here will be positive. So for the minimum to happen, it's only when this becomes equal to 0, right? Got it? So what happens when this is equal to 0? When it's equal to 0, only the minimum value occurs. And this they have already given us as delta. So what is fx minimum? A is greater than 0. If you multiply a into this, you'll get 4a minus delta. We know this is b squared of 4ac is delta over 4 times a. Is that the answer we want? Yeah. M1 is equal to delta over 4a. So, okay, once again, I'll say the whole thing again. So what we need to find is the minimum value of the function. The easiest way to find the minimum value of any function is to complete the square. And when you complete the square, you get a square term, right? And for a function, whole function to become minimum, the square term should be equal to 0, because whatever term you put in, it will be a positive. So for the minimum value, it will be 0. So if it's 0, as we can see here, the answer would be delta fx minimum is minus delta is b squared over 4a c divided by 4a. So did you get that? Any answers? Any questions? If you don't understand, also say, or if you have any other method, or you can say maybe you can do this method. So that also you can say. Right. If it's clear, let's move on to the next part. So show that the minimum value of f is this, and then let the minimum value of gx be m2, and deduce that a plus b plus c is this. Now, a very important thing, very important word in this thing is deduce. So you can't do the same thing we did like for fx and get the minimum value for gx. So we need to deduce it. So how do we do that? Now what we do is we compare between the two equations fx and gx, and then you substitute it in the answer we got, right? So let's do this again. Right, so fx was ax squared plus bx plus c, right? What is gx? Equal to a plus b plus c times x squared plus 2ab times x plus a, right? Now we need to compare between these two equations. So here, instead of a, what is the term here? A plus b plus c. Instead of b, what is the term here? 2a plus b. Instead of c, here this c is represented by a. We got the equation for fx, like fx minimum or m1 is equal to the fx minimum is equal to b minus b squared minus 4ac over 4a. Now instead of b, we need to put in the values for what we got here. Instead of b, we put in 2a plus b. Instead of a, we put in a plus b plus c. Instead of c, instead of a, sorry, the c we put a. So we need to substitute these values, and then we get the value for m2, right? So why do we do this? Because they said deduce. You can't just do what we did before and get the equation. If I'm not clear, or you need to understand something, this is okay. So what is m2? M2 is minus b squared. Instead of b squared, what we put? What is b here? 2a plus b minus 4ac, right? 4 times what is a? Instead of a, we put a plus b plus c times c. 4ac, what is c? A. Divide the whole thing by 4a, right? 4 times a. What is a? A is a plus b plus c. Now what we need to do is, now we need to simplify, but they're not asking the final answer. They're asking m2 in terms of m1, right? Deduce that this thing is equal to a times m1. So you need to remember the answer of m1 as well. M1 is minus b squared minus 4ac over 2a, right? So let's simplify this. Twice a, if you square it, 4a squared plus b squared, multiply this by this, multiplied by 2, that is 4ab, minus, if you multiply the whole thing, it'll get 4a squared plus 4b squared, sorry, plus 4ab plus 4ac, right? Divide the whole thing by 4 times a plus b plus c. Now, is there anything you can cancel? Okay. Remember, this minus is for the whole thing, okay? Minus is not just for this, minus is for the whole thing. So 4a squared can be cancelled. 4ab minus 4ab can be cancelled. So what is remaining? B squared minus 4ac over 4 times a plus b plus c, minus b squared minus 4ac over 4 times plus b plus c. So what is m1 again. M1 is minus b squared over 4ac. So we can write this like this. B squared minus 4ac is b squared minus 4ac over 4a. That is what is b squared. Sorry, m1. So we substitute that here. So instead of b squared minus 4ac, I'm putting this is delta times, right? B squared minus 4ac is delta, right? Delta over 4a is minus delta over 4a plus b plus c. Now we know delta over 4a. So multiply this by a and multiply this also by a. So what is this? M1, right? So M2 can be written as M1 times a divided by a plus b plus c. This is holding as M1. Then what is the answer we need? A plus b plus c times M2 is equal to a times M1. If we cross multiply, M2 times a plus b plus c is equal to a times M1, which is the answer we need. Do you get it? Right. So the next part is hence show that fx is greater than or equal to 0 for all real numbers, if and only if gx is greater than 0. So how do we prove that? Any ideas? Show that fx is greater than or equal to 0 for all real numbers only if gx is greater than 0. So any idea? Now if an entire function is greater than 0, then we can say that its minimum value, right? The minimum value of that function is also greater than 0. And that's obvious, right? If the entire function is always greater than 0, that means the minimum value of the function is always greater than 0. So, so how do you do that? So we know already got the minimum value of fx, that is m1. That means if fx is greater than 0, m1 is greater than 0. So if m1 is greater than 0, we need to show that if and only if gx is greater than or equal to 0. So how can gx be greater than or equal to 0? Same thing. If fx is greater than 0 means the minimum value is greater than 0. Then gx is greater than 0 means the minimum value is also greater than 0. So what we need to prove is if fx is greater than 0, we need to prove that gx is also greater than 0. So let's do that. So they are given that fx is greater than 0 or equal to 0. That means the minimum value of fx is also greater than or equal to 0, which means m1 is greater than or equal to 0. Sorry. Now we already wrote m1 in terms of m2, right? So a plus b plus c times m2 is equal to a times m1. That means m1 is equal to a plus b plus c times m2 divided by a. Right? So instead of m1, I'm writing a plus b plus c over a times m2 is greater than or equal to 0. Now what we need to prove is m2 is greater than 0. So how can we do that? Once again, look at the question. What have they given us? They have given us that let a is greater than 0. And also a plus b is greater plus c is greater than or equal to 0. So this is greater than 0. This is greater than 0. This whole thing they say is greater than or equal to 0, which means m2 is greater than 0. So what do you mean by m2 is greater than or equal to 0? M2 is the minimum value of m2 is greater than or equal to 0. So what does m2 is greater than or equal to 0 mean? The minimum value of gx is greater than or equal to 0, which means gx is greater than or equal to 0 for all values, for all x element of real numbers. Right? Understood? Okay, therefore, there are people from 2023 as well. So some people might be doing it this year, next year. That's okay, no problem. We'll go. Thanks for the message. Any questions? Please ask. So you got what I did, right? They're asking us to say that if fx is greater than or equal to 0 for all numbers, then that means gx also is greater than or equal to all numbers. For all numbers. What we did was we got the minimum value of fx. So if the minimum value of fx is greater than or equal to 0, we found out that the minimum value of gx is also greater than or equal to 0, which means gx itself is greater than or equal to 0. Right. So next, let's move on to the next question. B. So we given px is equal to this x cubed plus 2x squared plus 3x minus 1. Qx is this. So using remainder theorem, find that the remainder when divided is this by x minus 1, and the remainder when qx is divided by x minus 2. So we'll do that first. So as I said before, what is the remainder theorem? If you are dividing any value, anything by a certain value, then if you substitute that value, you get the remainder. So for the remainder, when px is divided by x minus 1, that's what they are given, is equal to, if you substitute x minus the root, if you substitute 1, that p1 will give you the remainder. That is, so p1 is equal to, what is px? Px is x cubed, so 1 cubed plus 2 into 1 plus 3 into 1 minus 1. So if you substitute 2 times 2 plus 3 is 5, 1 cancels off, the answer is 5. So the next thing is when q is divided by x minus 2. That means we substitute q2. Sorry, x equals 2 for q. So what is x again? Q again? X squared plus 3x plus 5. So instead of x, we substitute 2. It means 2 squared plus 3 into 2 plus 6. 2 squared plus 3 into 2 plus 6. That is 4. 4 plus 6 is 10. 10 plus 6 is 16. So which means the remainder when p1 is divided by x minus 1 is 5, and q2 when qx is divided by x minus 2 is 16. All right. What do you need to do next? So we have find the first one. So verify that px is equal to x minus 1 times qx plus 5. So px, so easiest way to do is take the right hand side and simplify. X minus 1 multiplied by qx, and we substitute and see whether this you get px. So x minus 1 times qx plus 5. So what is, okay, x minus 1 times qx plus 5. So we know qx, x minus, that is x minus 1 times, what is qx? X squared plus 3x plus 6 plus 5. Right? For qx, we substitute that. And now what we need to do is we simplify. X times this is x cubed plus 3x squared plus 6x minus x squared minus 1 multiplied by x squared minus x squared minus 3x minus 6 plus 5. Right? So if you simplify this, you get x cubed 3x squared minus x squared is plus 2x squared. 6x minus 3x is plus 3x. Minus 6 plus 5 is minus 1. Is this qx? Is this px? Yeah. So this is equal to px. So we verify that px is equal to x minus 1 times qx plus 5. And now they are asking, find the remainder when px is divided by this. X minus 1 times x minus 2. How to do that? Hmm? Now, there are many methods you can do this. Like you can divide the whole thing by, like if you take px and you divide the whole thing by this value using long division. That also you can do. So, but since we have already been given this, we already proved something, right? Px can be written as x minus 1 times qx plus 5. So, x minus 1, we can see, look at this, there's x minus 1 here. If we get x minus 2, also, we can get the remainder of this. So, what do I mean by this? I'll write it down. We prove that px is equal to x minus 1 times x squared plus 3x plus 6 plus 5. Right? Now, usually we can write any, like, for example, px can be, sorry, let's not decrease, fx can be written as something x times you divide by something and plus the remainder. This is the remainder theorem, right? So if you have fx and you divide it by a certain number, then you get another function of fx, another function of x multiplied by x minus a and plus the remainder. So if we can divide this, if we can make this equation in this format, where 5x is any number, but x minus a times, or x minus 1 times, x minus, what x minus 1 times, x minus 2. If we can get that in this form, and then if we get the remainder, that what is remaining here, then that will be the remainder, right? That's what we are trying to do. So we already have x minus 1. We need to get x minus 2 out of it. So how do we get x minus? Can we simplify this and get x minus 2? So one way to do is complete the square. Or before that, we'll take qx separately. Okay, qx is equal to this, right? X squared plus 3x plus 6. I need to make this in the format I get x minus 2 out. Now I don't think we can factorize this correctly, so we can x plus 2 outside. So can we make this as x plus 2 times something plus? Yeah. Now something you need to remember, like, don't just do the question in this is the question, so I'm doing that. But look at the whole question you're doing. Did you find something in the previous parts that you can use here? When you look at the first part, we found the remainder when qx is divided by x minus 2, right? Found it, right? So we can we use that here? Right? So if we divide x minus 2, so something times x minus 2 plus, if you divide by x minus 2, what is the remainder? We already know that, right? It's 5. Sorry, 60. Yeah, we counted before 16. So the answer here is 16. Now, what is, if it's x minus 2, what is the value here? X into, should be x, obviously. Now, this minus something, we don't know exactly what. So for that, I'll just put like a. So let's say x plus a. So we'll find what a is soon. So if you, this can be written as x squared, or like you can compare the coefficients. X squared plus minus 2x plus ax minus 2x square minus 2 plus a times x minus minus 2a plus 16, right? So if you take this, we can get the value of a. So minus 2 plus a is equal to, if you compare the coefficients of x, right? This 3, this is minus 2 plus a is equal to 3. That means a is equal to 5. Okay. That means qx is equal to x plus 5 into x minus 2 plus 16. Right? How did I get the 16 in the first place? Remember the first part of the question, we substitute and say if it's divided by x minus 2, the remainder is x, 16. So that's what we used here. So now we can substitute this in this equation and get the answer we need. So px can be written as x minus 1. Instead of this, what I put in is x plus 5, the same thing here, x plus 5 times x minus 2 plus 16. I put it here, right? I put it here. Plus 5. Now you simplify it, you get the answer. It's x minus 1 into x minus 2 into x plus 5. Then you multiply this, get 16x minus 16 plus 5. So as now you can see, we have taken this term out, and this is a like sort of a 5x term of x. So the what it remain was this side is the remainder. So 16x minus 16 plus 5 is 16x minus 16 plus 5 is minus 11. So this is the answer. Once again, I'll explain what I did. What we needed to do was find the remainder when px is divided by x minus 1 into x minus 2. We already knew when it's divided by x minus 1, it's like this. So can we also take this qx in the format? So we need it the answer in this format. Px is equal to x minus 1, x minus 2 something plus the remainder. So if we can get it that form, we can get the remainder. So what we did for that was we took qx. We already proved knew that the when it was divided by x minus 2, the remainder was 16. And using that, we substituted and got the value. So we can write qx as x plus 5 times x minus 2 plus 16. Right? And then we substitute that in the px equation. So x minus 1 times this. And then when we got this, the remainder, what we got was 16x minus 11. That's how we got the remainder. So that's the first question. It took a long time for that. Much more than I thought. So any questions on that? If you don't understand, please say, or if you understand also tell, like, okay, it's clear or something like that. So we can move on. Right. So okay, let's move on to the next question. We are not going to be able to do the whole question paper, the second part today. We will do as much as possible, hopefully. So the second question is this. Let n is an integer, is a positive integer. We are asked to state in the usual notation the binomial expansion for 1 plus x to the power n. And then we need to prove that n times ncr plus 1 divided by ncr is equal to this. Right? Okay. First, what is binomial expansion? So that's a theorem that we probably did before, like we have probably done. So one plus x to the power n can be written as using the NCR format. Write it. So 1 plus x to the power n, this question, can be written as NC0, like usually like just as a pattern, you can just NC1, NC2, and you go on until NCn. And what you do, x to the power, the same power as the what's in the middle. So x to the power 0 or x to the power 0 is 1. So that's okay. So x1, x2, up to xn. And also the whole thing is addition. Okay? This is basically binomial expansion. Or if you want to write in another way, simplified way, 1 to the x can be written as sigma NCR, sorry, NCR, x to the power, the same power here should come here, x to the power r. What is r? R goes from 0 to 10. Now, don't just write this, but also explain what is NCR. NCR is, this is coming in combinations and permutations lesson. So NCR is equal to factorial n divided by n minus 1, factorial r into n minus r factorial. So you know what factorial is. So NCR is equal to factorial n divided by factorial r into n minus r. So the reason I'm telling you like this is because in the marking scheme they they give marks also for this as well. So don't just write this, but also write this. So if you don't remember binomial expression, it's basically theorem. So what it means is 1 plus x to the power n. If it can be written in this particular format: x0, x1, x cube, same format, and then the coefficients are NCR, where r goes from 0 to n. So what is NCR? NCR is basically this. So to the value of n divided by value of r into n minus r value, all the whole thing factorial. Right. So the next thing is showing the usual notation that NCR plus 1 is divided by NCR is equal to n minus r over r plus 1. So we know what NCR is. What is the next thing? NCR plus 1, right? So we'll do that. NCR plus 1. So how do you do that? Just you substitute where there is r, substitute r plus 1. Factorial n divided by factorial r plus 1. Where there is r, I put r plus 1 into n minus r. So brackets r plus 1. Right? The whole thing factorial. Now, how do you simplify this? So what they're asking, NCR plus 1 divided by NCR. That is equal to factorial n divided by. Now, how can, okay, I'll write this again, r plus 1 factorial into minus r minus 1. So it's n minus r minus 1. You can see this one. Minus r minus 1 and factorial. And you multiply this. Oh, it's dividing, right? So dividing means multiply by the reciprocal. So the reciprocal of this is factorial r, factorial n minus r divided by factorial n. Now, how do you cancel factorial? So the easy way is, so in factorial can be cancelled off, right? So r plus 1 and r. Can you write r plus 1 factorial in terms of r? R factorial. So what is factorial? Like if a factorial 5 means 1 into 2 into 3 into 4 into 5. But this can also be written as, what is this? 1 into 2 into 3 into 4 can be written as factorial 4, right? So factorial 5 can be written as factorial 4 into 5. Same way, factorial r plus 1 can be written as factorial r into r plus 1. Right? So n minus r minus 1, and this is n minus r. So this is less like n minus r minus 1. This is n minus r. Can we write these two in similar terms? So this can be written as, sorry for always putting it in. So n minus r minus 1 factorial into n minus the next term n minus r. Sorry if it's not clear. So n minus r factorial can be plus n minus r minus 1 factorial into the next term n minus r. Now we can cancel this r factorial, n minus r factor minus 1 factorial. This. So the remaining answer is NCR plus 1 over NCR can be written as what is remaining? N minus r. So this term on top, n minus r divided by what is the term at the bottom? R plus 1. It's the answer we need. Right. N minus r over r plus 1. Any questions? Okay. So then they have given that the coefficients of xr plus 1, xr plus 2 taken in order are in the ratio 1:2:3. Show that n equals this and 4 r equals this. How do you show that? First, understand what the question is. So as we said before, this NCR that in binomial expansion, we can write these terms as in the form of NCR x times r, in that form, right? So like in the whole thing, there's, for example, if say NC, like what do we need? NC r, xr plus 1, xr plus 2. So what is if it is xr, then the NC r. xr plus 1 means it's NCR plus 1 x times r plus 1 plus NCR plus 2 x times r plus 2, and it goes on. So these are three particular terms in the binomial expansion that we did before. xr plus 1, xr plus 2. Now they have given that the coefficients of this in order of the binomial expansion is 1:2:3. So what is the coefficient of xr? NCR. What is the coefficient of xr plus 1? NCR plus 1. Coefficient of xr plus 2? NCR plus 2. So they have given the ratios of this to this to this is 1:2:3. So a ratio, as you know, can be written as, so I'll do NCR is to NCR plus 1 is to NCR plus 2 is 1:2:3. So the ratio can be written as a fraction, right? So NCR divided by, we'll take this divided by this and this divided by this. NCR plus 1 divided by NCR is equal to 2 over 1. And NCR plus 2 divided by NCR plus 1 is equal to 3 over 2. Right? So can we simplify this? Do we know this for the first? Have you seen this somewhere before? Just prove it in the early equation, right? NCR plus 1 divided by NCR is equal to n minus r over r plus 1. So we need to find n and r, right? So we can substitute this here. N minus r, what is this? N minus r over r plus 1 is equal to 2. So if you expand this, you get n minus r is equal to twice, if you cross multiply, twice r plus 2. That means n minus r, or n minus r, if you take all the terms to the one side, n minus 3r is equal to 2. So let's take this equation number 1. Now, can we also get a value for this? We can, using the same equation we got before, what we got was NCR plus 1 divided by R is equal to N minus R over R plus 1. So, but this same is very similar to this, right? So, but here is R plus 2 divided by R plus 1. So, that means where there is R, you can substitute R plus 1. So, R plus 1, if you substitute R plus 1 here, it will become R plus 2. Substitute R plus 1, it will become R plus 1. So, N minus R or R plus 1. Now, instead of this value, it's actually N minus, where you put R plus 1. Right? I'm writing from this equation. Okay. Where you put R, because R plus 1. Plus 1. Right? Is equal to 3 over 2. To simplify this, you get N minus R minus 1 times 2. Get the 2 here, and is equal to 3 times R plus 2. See, times R plus 2. Which, if you simplify this, we get 2n minus 2r minus 3r. So this is 3r. If you get it to the left side, it will be minus 3r. Minus 3r minus 2r is minus 5r. So minus into 1 is minus 1 into 2 is 2 minus 2. With 3 into 2 is 6. If you take it to the other side, 6 in the plus 6 minus 2. If you take the other side, becomes plus 2. 6 plus 2 is equal to 8. These are the two equations we got. Now we know n minus 5r. Sorry, we know n, and we know there are two unknown values, n and r. We have two equations, so we can solve these two and find n and r. So before going, I'll just explain what did they get. We got, they have given that the ratio between these two are 1:2:3, and so that means the fraction or the division between this and this is equal to 2/1. But we already know what this is from the previous question, what we did. We got this. Substitute that, we got an equation. So we know that R plus 1 and R plus this is very similar to this. The R goes to R plus 1. So when you substitute R plus 1 in terms of R, then you get this equation 2n minus 5r is equal to 8. Now by solving these two equations, we can get the answer. So how do you solve? This is 2n, this is n. So the easiest way to do is multiply 1 by 2 and subtract from 2. Multiply the first equation. Okay, this is minus 3r multiplied is minus 6r. So because it's easier to get the minus, we'll do 2 minus the second equation minus the first equation multiplied by 2. That means that 2n will cancel. Right? Second equation multiplied by first equation multiplied by 2. Sorry, second equation minus first multiplied by 2. So the second equation multiplied by is minus 5r minus 3r. If you multiply by 2 is minus 6r is equal to, n cancels off, 8 minus 2 times 2 is this is 2. 2 times 2 is 4. So minus minus becomes plus. 6r minus r becomes r. 8 minus 4 is 4. So r is equal to 4. From equation number 1, we can say n is equal to 2 plus 3r. That is equal to 2 plus 3 times what is r? 4. 3 times 4 is 12. 12 plus 2 is 14. So n is equal to 4 and r is equal to 14. Is that the answer? Yeah, n is equal to 14, r is equal to 4. So did you get that? Any questions? Is it clear? If you haven't done combination and permutation, it's pretty simple. So in CR, you saw the equation, right? So factorial that equation, that's all you need. And binomial expansion basically means the expansion what we did. That's just two theorems that you just need to remember. If you haven't studied that, it's not a big deal. So that's it. So can we go to the next question?
Yes, sir.
Any question? Yeah. Okay. No questions, right? Nice. Okay, let's move on to the next. Finally, somebody answered. Right. Let's move on. So the next question is, we need to get, if you let UR is equal to this, we have even given UR, and FR is this. Find the values such that UR is equal to this minus this. Now you probably have done serious questions. So what we basically have to do is, at the end you can see that we need to find the summation of all the terms of UR when R goes from 1 to n. That's what we need to do. But before that, they are giving us a step. Can we break down UR in these terms? FR over this thing minus FR plus 1 into this thing. What is FR? They have given us A into R plus B. Let's do this. UR is equal to 10R plus 9, 2R minus 3, 2R minus 1, 2R plus 1. This can be written as in this format: 2R minus 1, 2R minus 3, 2R minus 1. Now for FR, we can write AR times AR plus B. So for FR plus 1, what is that? FR plus 1 is where there is R, substitute R plus 1. Okay. So R becomes R plus 1. Here R becomes R plus 1. So it will become 2R minus 1, 2R plus 1. Plus 1 into here is now FR plus 1, right? So R plus 1 times, instead of R, we put R plus 1 again, plus B. Okay. Sorry for the small letters. Right. So you need to simplify this and get the values of R, right? What is FR? Sorry, A and B. We need to get the values of A and B. Right. Now we need to simplify this. So how do you simplify? We already know what UR is, right? I wrote 10R plus 9. So the easiest way to simplify is you multiply the whole thing by the common denominator. So multiply all these things by 2R minus 3, 2R minus 1, and 2R plus 1. So this is the left hand side. This is the right hand side. Okay, so what's the right hand side would be? The whole denominator goes off. That means 10R plus 9 is equal to, multiply this by this. What is remaining? 2R minus 3 cancels off, 2R minus 1 cancels off, 2R plus 1 remains. So it's R into R plus B into 2R plus minus. Now we have AR plus B, sorry, R plus 1 into A times R plus 1. So if you expand this, it will be AR plus A plus B, right? AR plus A plus B times what? 2R minus 1 cancels off, 2R plus 1 cancels off, what's remaining is 2R minus 3. So you multiply that as well, 2R minus 3. Now this question is a bit of a simplification question, so be a bit careful because sometimes you might mess up, like one term might go off and then the whole thing. So be careful with the simplification. So let's simplify. It's better, like sometimes some people can like get the answer, like compare the coefficients directly, R squared but it's a bit difficult in this because there are three terms. Okay, so it's better to let's expand the whole, all the terms and then come to the answer. Right, 10r plus 9 is equal to r times ar plus. So we can write this here. R times ar is ar square. R times b is br. So shall we do this as well? Because it will be easier to simplify. Yeah, we'll do this too. R plus 1 into R minus 3. That might be a bit easier. So that would be R times 2R is 2R square. R plus R times 3 is minus 3R plus 2R minus 3R plus 2R becomes minus R. 1 into 3 is minus 3. So this is these two, right? These two terms I simplify this as this. Now we'll open the brackets. So if we get this, AR times 2R is 2AR square, AR cube. Okay, this into this. So this into this is AR square plus BR times 2R is plus 2BR. BR times 1 is plus B. So BR times 1 is BR. Okay, BR times 2R is 2BR square. Okay, these small mistakes might take a lot of time to think if you get a mistake, right? So 2R times AR is twice AR square. So AR cube. 2R times A is okay because of it's A plus B. No, it's easier. So 2R times A is 2A R square. 2R times 2R square times B is 2B R square. Then minus R. Minus R times AR is minus AR square. Minus R times A is minus AR. Minus R times B is minus BR. Then minus 3 is minus 3AR minus 3A minus 3A minus 3B. Right. Okay, before cutting the stuff off, like look at if you can see if the simplification is correct. Otherwise, at the other step, you get stuck. So 2AR square. Okay, I think it's okay. If there's any mistake also you can say. Right, it seems okay. So now let's see, are there anything terms that we can cancel off? 2AR square, 2AR cube, 2AR cube, this is minus. So we can cancel off. AR square, 2AR square, minus A, so 2AR square minus AR square is plus AR square. And we have AR square here, so these three can be cancelled off. Right? Now 2BR square, we have 2BR squared here, this can be cancelled off. So we have BR here. We can't cancel out because it's minus BR. So it's minus AR minus 3AR. So minus AR minus 3R can be written as minus 4AR minus 3A minus 3B. Right, I think that's all right. So if we simplify this, we'll get BR minus minus becomes plus BR plus 4AR plus 3A plus 3B. Right? So now what we need to do, what we did was we simplified the right side. The left side is still 10R plus N. So we need to compare the coefficients. For that, we write the whole thing in terms of R and the constants. So take R out. If you take R out, what is BR plus 2BR is 2B, sorry, 2BR. That means 2B. If you take here plus 4A, that's it, right? And then the constant terms, 3A plus 3B, right? This is just simplification. So now what we do is we compare the coefficients. So if we compare the coefficients of x of r. So in the left hand side, what is the coefficient of r? 10. So 10 is equal to what is here? 2b plus OA. So that is equation number 1. Or you can simplify this further. All divisible by 5, divisible by 2. So 5 is equal to b plus 2a. Equation number 1. Now we compare the constants. So what is the constant here? 9. And is equal to 3a plus 3b. Also can be simplified. Also divisible by 3. So is 3 is equal to a plus b. Right? Now we just have to simplify this. So b is here, b is here. We can just subtract these two and cancel off b. So 1, equation 1 minus equation 2. So b minus b cancels off. 2a minus a becomes a is equal to 5 minus 3 becomes 8. Sorry, 5 minus 3 becomes 2. Right? A is equal to 2. So from equation number 2, we can say b is equal to 3 minus a. What is a? 2 is equal to 1. So b is equal to 1 and a is equal to 2. Right? So if what do we do all this for? A, what is a, what is b? So they have been given that fr is equal to r times ar plus b. So that's what we found. So what is fr? Fr can be written as r times 2b. Sorry, a is r. So 2r. So a is 2. So it's 2r plus 1. Okay, that's fr. Any questions? So that was just a simplification. So the next thing we need to do is we need to check if this UR is equal to in this format. Now, why, like, how do we do a C? So UR is given in this format, and we need to show that the sigma, the summation of all UR onto n, is equal to this. Now, if you remember, like if you have a summation question like this, the usual form you do is you write UR in terms of two stuff. So let's say use F here. So let's say HR minus or plus or minus HR plus 1. If you write it in this format and then you substitute values. So U1 is equal to H1 minus H2. So then U2 would be equal to H2 minus H3. Now, if you add this stuff, so H2 minus H will be cancelled off. So if you are UN minus 1 is equal to Hn minus 1 minus Hn. So you will be able to add this stuff. So that's why we do it in this format. So we need to write it in this one. U1 is equal to H1 minus H2 in that format. So can we write this? So we have been given UR is equal to FR this thing minus FR that. Can we write this whole term FR over 2R minus 3, 2R minus 1 as 1 like HR, something like that, or GR, like something like that, minus GR plus 1. So can we write it in that term, that format? Let's see. So now what is GR? We already know what GR is. So sorry, FR is. So we can write a term called GR. GR is equal to this first term, FR over 2R minus 3 times 2R minus 1. FR is equal to this. So we already found what FR was, right? So what is G? Now, can we write what is GR plus 1? If we substitute R plus 1 to all these terms, what will we get? If it's 2R plus 1, it will be 2R plus 2 minus 3. That means 2R minus 1. Then if you substitute R plus 1 here, you will get substituents there. So 2r plus 3 will become, if you put r equals r plus 1, it will be 2r minus 1. If you substitute 2r for 2r minus 1 for this value, if you substitute r plus 1, you will get 2 into r is 2r, plus 1 is 2 plus 2, 2, then you get 2r plus 1. Right, now look at the answer again. Here the denominator is 2r minus 1, 2r plus 1. Okay, so if we put gr like r plus 1 for this, we'll get the denominators as this. So that's okay. So the top part, fr plus 1 is already correct, right? We have fr, we just substitute r plus 1, where fr is, we substitute r plus 1, then that's correct. So f r plus 1 times, if you substitute gr, 2r plus 1, sorry, 2r minus 1 into 2r plus 1. So if you substituency, so where there's r, you substitute r plus 1, and then you get the same this answer. So isn't this the same thing? This can be written as gr. This is written as gr plus 1. That's what we're going to do. So ur can be written as gr minus gr plus 1. So we got it in this. Like, why did we do all this? We need to get it in this format, because then only it's easier to simplify. So what we need to do is r equals 0 to n, r equals 1 to n. We need to get the summation. So when r is equal to 1, u1 is equal to g1 minus 1 plus 1 is 2, g2. When r is equal to 2, u2 is equal to g2 minus g3. We can go on like this until, let's say, r is equal to n minus 1. So un minus 1 is equal to g times n minus 1. Add 1, it will be gn. So r equals n up to n, right? 1 to n. Un is equal to gn minus gn plus 1. So we can add this all, add the whole thing, summation. Minus g2 plus g2 cancels off. And then in a similar way, all this cancels off. Minus gn cancels off. What is remaining? 1 sigma. So this is the addition of all of this. ur, where r is equal to 1 to n. What is g? This is the answer is g1 minus gn plus 1. Right? So what is g1? So this is minus. What is g1? What is gr? Gr is fr over 2r minus 1 times 2. Right? What is fr? Fr is equal to 2 into, fr is equal to 2 times, fr is equal to r times 2r plus 1. Right? So if we substitute that, we will get the answer. So g1 is equal to 2 times, for r I substitute 1, 2 times r, there is 1 plus 1. This is fr. Okay. Divide the whole thing by 2r plus value 2r minus 3, right? Where r is substitute 1, that is 2 minus 3. Okay. Then minus. So what is fr plus 1? Fr plus 1 is equal to twice. So r plus 1 into 2r plus, let me start with this. So fr plus 1 is equal to r plus 1 into twice r plus 1 plus 1, right? So because 2a plus b, we got a and b. So fr plus f. Okay, so that's this thing. So we can get g n plus 1 is equal to r plus 1 into, this is simplify, this is 2r plus 3, divide the whole thing by what's the term in the bottom, get 2r minus 1. I get this from here. Okay, 2r minus 1 into 2r plus 1. Now, before simplifying, we'll look at the answer a bit and see if it's in the format we need. Okay, this is n plus 1, right? So substitute n, sorry, this is not r, substitute n, okay? N. Okay, now we need to get it in this format. Look at this, 4n square minus 1. So can you get that? Yeah, 2n minus 1, 2n plus 1 is completing the difference between two squares. If you multiply, get 4n square plus 1, 4n square minus 1. Then the top is what we need. So we simplify this. When we simplify this, g and g1, you'll get 2 plus 2, this 2 plus this 3, minus 1, that is minus 3, right? So sigma r equals 1 to n will give you minus 3 minus n plus 1 times 2n plus 3. Divide the whole thing by 4n square minus 1. Right? Is that the answer? Yeah. For all positive integers. Any questions? You understand?
Yes, sir.
Right. So the last part is we need to show that the infinite series is convergent and find the sum. So how do you find this convergent? What do you mean by convergent? So convergent means if the r we first said r goes from 1 to n, but what if it goes until infinity? So if this goes until infinity, if the series gives a finite value, the answer for the from r to 1, r equals 1 to infinity is a finite value, then we say that the series is convergent, and find its sum. So if there is convergent, you can find a finite value, right? So that's what we're going to do now. Yeah. So the last part is we need to find if it's convergent. So we need to put r equals 1 to infinity. Now you can't just substitute infinity here, because you get infinity and then here also you'll get infinity. Infinity times infinity is not defined. So when you're always substituting infinity, first of all, make it in the format that you can put infinity. That means you format 1 over n. So you take all the, because 1 over infinity is 0. So you always write it in that format first. So minus 3 minus. Now, if you take n outside here, it will be n 1 plus 1 over n. If you take n out here, then it's n squared outside. There will be 2 plus 3 over n. And then 4n squared minus 1. If you take n squared outside, that is 4 minus 1 over n squared. Right? So these two can be cancelled out. Right? So now we can substitute infinity. So now when when n tends to infinity, right? Sigma n equals 1 to infinity is equal to minus 3 minus 1 plus what is n is infinity, right? 1 over infinity is 0 into 2 plus what is 3 over infinity? It's also 0. Divided by 4 over 4 minus 1 over n square. 1 over infinity is 0. So now it's you can see it's a finite value, right? Minus 3. 1 times 2 is 2 divided by 4. That is minus half. What's the answer they have? Okay, they have given the answer. So we need to find, so 1 times 2 is 2, divided by 2 is half. So minus half. The answer is 2 twice 3 is 6 minus 7 over 2. Right? So we found that this is actually convergent to a value. So write that. So therefore, sigma r equals 1 to infinity is convergent. And the sum value is minus 7 over 2. Any questions on that? you get it? Okay.
Yes, sir.
Right. So we did 12 two questions. So shall we take a small break before coming to the next one? It's almost 2 hours, right? We got like 1 more hour to go. We can maybe finish 1 or 2 questions. Maybe. Is that okay? Shall we continue?
Yes, sir.
Okay, then we'll go. We have 10 minutes break and come back. Okay.
Okay, sir.
11. Okay, 11:10 we'll start. Right. So we discussed 2 questions on the 11th and the 12th. So next we'll be moving on to the 13th one. So as you can see, the first part is about matrices. The second part is about complex numbers. So now matrices, most people like think it's like easy subject, easy lesson, and but like yeah, it's easy. But the thing is, matrices are applied a lot in everywhere. So for example, if you take engineering, like when you're going doing equations and stuff, you get a lot of stuff you can do using matrices. And even if you're looking, like for example, like you're probably looking from computer screen right now, right? So all these computer screens are made out of pixels. So all these pixel values have different color values, like RGB values. So these values, all of them are representatives of matrices. So it's pretty important subject when if you come to university, you'll probably do a lot of matrices. So yeah, let's start with the question. Okay? The So the first question is A is given as -4, -6, 3, 5. X is this, Y is this. So find real constant lambda and mu such that Ax is equal to lambda x and Y is equal to mu y. Okay, let's. Right. So A is given as -4, -6, 3, 5. X is -1, 1, and Y is -2, 1. So what we need to do is, what they're asking is, find such that A times X is equal to lambda times X. So let's mark, that means A multiplied by X should be a something. So what we'll do is do A times X. So what is A? -4, -6, 3, 5. And what is X? -1, 1. Now when you multiply two matrices, what you need to remember is there's only one simple condition. Like if you can write the rows and columns. Rows is how many rows? Rows are this direction. Columns are in this direction. There are 2 rows and 2 columns. So 2 by 2 matrix. This can be written as how many rows? 2 rows. How many columns? 1 column. Right. So the way you can say, like, can these 2 matrices be multiplied? These two values should be equal. 2 and 2. Only if this is equal, you can multiply these 2 values, these 2 matrices, and the answer, the final output, would be 2 by 1 matrix. So the final answer would be 2 by 1 matrix. So how do you multiply? Okay, so that's it. So these are same. It can be multiplied. So let's multiply. So how do you multiply? Row multiplied by column, right? -4 multiplied by -1 plus -6 multiplied by 1. That will give you the first value. So let's write -4 times -1 is plus 4, minus 6 times 1 is minus 6, minus 6. This is the first value. So we know there are only two similar, it will be a matrix similar to this because only 2 by 1 matrix will come. So next row, you go 3, 5. So 3 multiplied by the first term is minus 1, 5 multiplied by 1. So 3 times minus 1 is minus 3, 5 times 1 is 5. So the answer is minus 4 plus is minus 2, minus 3 plus 5 is 2, and 2 plus 2 times 1 matrix. Now, what they're asking is to write it in terms of x, right? It should be equal to lambda times x. So you can see lambda is equal to minus 1 times 1. So this can be, if you take 2 out, you can write this as minus 1 times 1, right? So like if there's a constant, if you multiply, then all the values get multiplied by that constant. So we can write it as this. What is this? X. So this is equal to twice x. They have given that ax is equal to lambda x. Therefore, lambda is equal to 2. That's the first part. Right? Understood?
Yes, sir.
Right. So next, what we need to do, next part is show that ay is equal to mu y. Y we need to find mu. So we need to multiply a by y. So let's do that. So a is equal to, so a y is equal to, what is a? Minus 4, minus 6, 3, 5, multiplied by y is minus 2 and 1. Minus 1, 1. So if you multiply these two, once again, the row multiplied by the column. Minus 4 into minus 2 is minus this into this into this. Okay. Minus 4 into minus 2 is plus 8. Minus 6 into 1 is minus 6. This 3 times 5, 3 into 5, 3 into minus 2 is minus 6. 5 into 1 is plus 5. Right? If you simplify, this is 8 minus 6 is 2. Minus 6 plus 1 is minus 1. Is this related to y? Y is minus 2 into 1, right? Okay, so there's a minus 1 difference in what we got here. So yeah, so we can write this as minus 1 times 2 minus 2 1 is equal to minus 1 times y as y. So they have given ay is equal to mu y, means mu is equal to minus 1, right? Right? So the next thing is find the inverse. Now p, they have given p is equal to this. We need to find the inverse of p and ap. That means multiply a by p and then show that this is this. So how do you find the inverse of a matrix? Any answer? So there are, I'd say, two methods, like might be a method, but there are two methods to get the the inverse of a matrix. So one is you can, this property that like one is like you get the, if you have a b c d and you get something called determinant of a. So determinant of ab ad minus b ad minus bc. So times, and then there's a small formula like you multiply this the change the two positions of the terms and minus value of these two terms. So that's one method, and the other one is the theorem, or the theorem behind this is, if you multiply any matrix by its inverse, you will get the relevant identity matrix. So what is identity matrix? That is, if you have, like, for example, if it's a 2 by 2 matrix, all the diagonals are 1, others are 0. So that's what an identity matrix is. So we'll use this formula for this question. Okay. So we need to find P inverse, right? What is P? 1. Okay, let's see what's P. P is -1, -2, 1, 1, multiplied by P inverse. The P inverse should also be the same format. So 2 by 2 matrix. So we don't know the values. Let's put as A, B, C, D. Okay. Is equal to, what is the identity matrix of this? Because it's 2 by 2, 1, 1, 0, 0. Okay. Okay, you can see that. So this is P. This is the matrix we are trying to find, and is equal to this. So how do you you can use the same thing we used before, multiply. So -1 times A. So -1 times A is this multiplied by this, okay? Minus A plus minus A minus 2C would give you this particular value, is equal to 1. Equation number 1. Next is -1 into this. So minus B minus 2D will give you this value, that is equal to 0. Next is this multiplied by this. So 1 into A is A plus C is equal to this value, 0. Then you get this into this. B plus D is equal to this value, that is 1. We have 4 equations, 4 unknowns. You can just simplify and get the answer. So how do you simplify? So you can see here A and C, A and C, B and D, B and D. So we can use these equations to get the answer. So if you add 1 and 2, 1 and 3, you can cancel A off, right, and get the value of C. So that will give you minus A plus C cancels off. 2C plus C minus 2C plus C minus C is equal to 1. This means C is equal to -1. So from 1, or let's say from 2, A is equal to, sorry, from 3, right? A is equal to minus C. This means A is equal to 1. C is equal to -1. A is equal to -1. A is equal to +1. So by adding then these 2 and 4, 2 plus 4, D cancels off. So minus 2D plus D is minus D is equal to 1 plus 0 is 1. So D is equal to -1. From 4, B is equal to B is equal to 1 minus D, that is equal to 1 minus, what is D, -1, -1, that is equal to minus becomes plus, 1 plus 1, 2. Right? So the answer we got, A is equal to 1, B is equal to 2, C is equal to -1, and D is equal to -1. That means inverse, or P inverse, I'll write it here, is equal to, what is A, 1, B, 2, C, -1, D is -1. Right, this is the answer for P inverse. The question was find P inverse. Right, did you get that part? Is that clear?
Yes, sir. Understood.
Right. Next, we need to find AP. They ask find P inverse and then AP. So let's find AP. So the same thing, you need to multiply A by P. So AP is equal to what is A? A is -4, -6, 3, 5. What is P? -1, -2, 1. Right? So you multiply these two. The answer you get is this into this, -1, -4, -6. This is first thing. -4 into -2 is +8. -6 into -1 is -6. Yes. Then this 3 times this is -3. 5 plus 5. 3 times minus is -2, -6. 5 times 1 is +5. Simplify. 4 minus 6 is 4 minus 6 is -2. 8 minus 6 is 2. -3 is -2. Sorry, +2. -6 is -1. Right? So what the next, that is AP. We found P inverse and AP. So we need to show that P inverse into AP is equal to D where D is this. So we know P inverse, we know AP. We need to just find P inverse times AP. So P inverse is times AP is equal to, we need P inverse, right? We got P inverse as 1, 2, -1, 1, -1, -1 into, now AP is 2, -2, 2, 2, -1, right? So multiply it again. 1 times -2 is -2. 2 times 2 is +4. So -2, that is 2. 2 times -1, -2. So -1 times this is +2. -2. -1 times 2 is -2. Minus minus plus 1. 1 times 1 is 1. So -2 plus 4 is +2. 2 minus 2 is 0. 2 minus 2 is 0. -2 plus 1 is -1. This, yeah, so this is the answer we need. This is equal to D. Right? Not that difficult, I think. Do you get it?
Yes, sir.
Right. So next we need, so I'll move on to the next, right? So it's matrices simply, like you need to know is how to multiply matrices, add matrices, and you multiply by constants like lambda, x mu, and also how to find the inverse. So those are basically some things you need to know about matrices. Now we'll move on to the next question. It's about complex numbers in an Argan diagram. So what is an Argan diagram? So Argan diagram is used to represent a complex number. A complex number is something that is in the form of x plus iy. What is I? I is equal to √-1. Because √-1 we can't represent it it's as a real number. So that's why we call it a complex number or an imaginary number. So we have been given that in an Argan diagram there are 2 points, A and B. So A such that point B is such that OB is equal to twice the length of A, OA, and AOB is 5/4. O is the origin. So we need to find the complex number represented by point B. Right. So basically an Argan diagram is simply the same thing as an XY coordinate, but here the axes would be, here we represent now x plus iy format, right? That's a complex number. So how do you represent a complex number? In the if there's a complex number Z, we represent that point with the coordinates x and y. The x direction and y direction. That's how we represent a complex number. So this coordinate is the x part. So x part we call the real part, and the y part we call the imaginary part. So this is the imaginary axis. and this is the real axis, okay, not xy. Right. So what they have been given us is there's a point A represents the complex number 2 plus I. Now 2 plus I is, what is 2 plus I? So x is what? 2. Y is y times I, that is 1. So x plus 2 plus iy represents the point 2 and 1. 2x, and here is point A. So it's 2 and 1. 2 plus I y. 2 plus I. Okay, so this is the representing is that the point A represents the complex number 2 plus I. Now what they are telling us is there's another complex number B such that the length of OB is twice the length of OA. Now what is O? O is the origin. This is O. So if it is A, there's a complex number that is in point B where the length of OB is twice the length of OA. That's one thing we have been given. And the other thing is AOB, the angle between AOB is 5 by 4. What is 5 by 4 is 45. So where, and AOB is measured counterclockwise from OA. So counterclockwise means in this direction, right? So in this direction, 5 by 4, and then also the length is given as twice the length of OA. So if there's a point B here, this angle counterclockwise measured 5 by 4, in this distance OB is equal to twice distance of OA. So that's what we have been given. Now what they're asking us to do is find the complex number represented by the point B. Okay, now OB cos 40 was equal to OA. We can't directly say that, no? So if OB cos 45 is equal to OA, that means OAB should be a right angle triangle. Only if then OB cos 45 will become OA, right? Did you understand that? Right? So we can't take that. Only if the when like physics and stuff you different you get it, like you 45 towards the angle cos away from the angle sine, but that we get if it's a right angle triangle only. Now if in complex numbers there's a theorem. So if we have a, so I'll tell the answer. So if we have a complex number, a certain complex number, and we move that complex number along a particular angle, there's a equation or the theorem that we can use to get the position of the new complex number. So I'll write that here. So the theorem we need is this. So if we have imaginary axis, real axis, this is not the question, right? This is the theorem I'm trying to tell you. So if there's an angle P Z. So some people said they haven't done complex numbers. So complex numbers, as I said, simply just x plus z equals x plus iy. I means I equals root minus 1, okay? Because it's a complex number, we represented it this form. There's another way you can represent the complex number. In Argan diagram, now this is the point P that is representing the complex number Z. This is the angle theta, right? Now, and there's another way you can represent it. That is how you say Z is equal to Z equal to I sine theta, I cos theta, cos theta plus I sine theta. What is the angle? Theta. So cos theta plus I sine theta. So that is how we can represent a complex number. That's another way you can represent it. One is x plus iy. This is the angle. So this angle between the complex number and the real axis is called the argument of the complex number. So if somebody says arg z, they simply mean the angle between this. So this is one way you can write. Now the theorem that we need to do is, if we move this, if we rotate this and this complex number in the anti-clockwise direction, now let's say this new point is pz dash. Now it's a new complex number because there's a new it's a new position. So the theorem is, if you rotate this by angle say alpha, the new the new location is equal to the old complex number z, multiply this by, now it's cos this angle, we turned it by alpha plus I sine alpha. Now if it's anti-clockwise, it's my plus, otherwise it's minus. So this is the theorem. Like, if you haven't done compression, this is the theorem. Like, you'll probably learn it. So if you have z, you have z at a certain point, and we need to get, if you rotate the z by a different point, say an angle alpha, the new z can be written as the old times z multiplied by cos alpha plus I sine alpha. Okay, this is a theorem. So this is what we are going to use to find this new point. Okay. Any questions? Right. So right. So now what we'll do is, now instead of, now this is given as twice b. Now if we rotate this angle here, we'll get at the exactly the half point. So we'll first find this. If you rotate this angle by this, the coordinate here, and then we'll get the coordinate of sorry, the z complex number of this. So let's take this point as z1, right? This is the same alpha a that is rotated at an angle 5/4, not OB. Okay. So the new z1 can be written as z times cos alpha plus I sine alpha. Now what is alpha? What is z? What is z? This complex number, that is 2 plus I. And then what is cos alpha? Cos, what is the alpha here? We rotated it by angle 5/4 plus I times sine 5/4. Okay. So what is 5/4? Cos 5/4? 1 over root 2. Sine 5/4? 1 over root 2. So we can take 1 over root 2 outside because it's common. Get 2 plus I here. What is remaining here? 1 plus I. If we simplify this, 1 over root 2 times 2 times this is 2 plus twice I plus I, that is 3I plus I squared. Now I said before, what is I? I is equal to root minus 1. Root minus 1. So I square is equal to minus 1. Okay. Try 3I. Okay. So the answer would be 1 over root 2. 2 minus 1 is 1 plus 3I. Okay, got it up to that point? What we found is this particular is in one value. Okay, we rotated A by this and we found this point. Now what we need to find is B. Now there's another thing. Now because the OB is given as twice OA, okay, OA. So it's the same thing, but what we need to do is multiply the value by the sorry. So it's given OB is equal to twice OA, right? So OA dash is OA. Let's take A dash as this point. So it's in the same line. So it's the same complex number, but it needs to be multiplied by a factor of 2. So simply you need to do is the OB is equal to twice Z dash, because Z dash we found Z1. Z1 we found this, you just need to multiply it by 2 because the size of OB is twice the size of OA. That is 2 twice 1 over root 2 1 plus 3i. So root 2 multiplied by 2 is root 2. That will be root 2 times 1 plus 3i. This is how you get the OB value for OB, or the complex number represented by the point B. So this is point B, Z as point B. Okay.
Okay, sir.
Right. The next thing they are asking is, complex numbers is not a very big lesson. Like, you can, if you just know the sum of the theory, well, you can just need to apply it properly. So if you haven't learned it yet, maybe it's a bit sounds a bit complex. Complex numbers are not very complex, but okay. So the next thing is we need to find the, okay, we found the number represented by B. So now we need to find the complex number represented by point C, such that OABCB is a parallelogram. Right? Did you get the question? So how do you do that? So for that, we have another theorem we can use. Now, if you have two complex numbers, yeah, the video will be recorded and I think it will be uploaded on YouTube. I think. Yeah. So, okay. Now, when we move on to the next part, we need to do. So this is A, this is B. What is C such that A is a parallelogram. So if you extend this, sorry about that. So this is a parallelogram. This is represents point C. So what we need to do is find the point C such that A is a ABCD, OABC is a parallelogram. Right? So now this is a theorem, another theorem. Okay, so if you have two complex numbers, what is the value? So if you have two complex numbers, Z1 and Z2, now the answer is, so if you have two complex numbers, Z1, Z2, represented by 2 points in the Argan diagram, okay? If you add these two, Z1 plus Z2, the value represented is the value of this coordinate. This coordinate represents Z1 plus Z2. Now, just to show you how that came, so the point here is X and Y, right? X1, Y1. Point here is X2, call it X2, Y2. The point here is actually X1 plus Y1 and Y1 plus, sorry, X1 plus X2 and Y1 plus Y2. If we add Z1 plus Z2, Z1 is X1 plus IY1. Z2 is X plus 1, Z2 is X2 plus IY2. So if you add these two, it will be X1 plus X2 times I times Y1 plus Y2. So those two coordinates we need, X1 plus X2, Y1 plus Y2. So simply what you need to do to get the point C, coordinate C is add the two numbers Z1 plus Z2. The value set is A and value set B. That's all you need to do. So for the coordinates of C, is equal to, what is the value at A? Is it the complex number at A is 2 plus I plus the what we just found, Z plus Z at B. Okay, that is equal to plus, sorry, root 2 times. What's the answer? Root 2 times 1 plus 3i. So it's, when you write it, always try to write in the format of a X plus IY form. So you get all the normal, the real numbers together and the complex numbers together. So here you say 2 and you get a root 2 here. So you get 2 plus root 2 here. And then if you take the I outside, I is the imaginary part, then you get here 1 plus here is root 3 root 2, right? 3 times root 2, which is the answer we need. Right? Do you get it? So hope there's no questions. So I'll move on to the next part. So the final part is Z. So we have done the second one. So next is C. So Z is a complex number, and W is also something, a complex number with Z as part of it, and it's also given that IMW. Now what is IMW means? I said there are two parts in a complex number: a real part and an imaginary part. The real part is the X part, or the one without the I, and the imaginary part is uh, the part with I. So it says the imaginary part of W is -1. That means the coefficient of the items is -1. And it's also given that the modulus value of W minus 1 plus I is equal to 5. We need to find the value of Z. So this is what we need to do. So whenever you get, now look at the W. W is 2 over 1 plus I, 5Z over 2 plus I. Now it's a bit difficult when the denominator, there's I in the denominator. So what you do is we need to remove those values. So how do we do that? You multiply it by the conjugate. I hope you know what conjugate is. It's basically if 2 is 1 plus I, the conjugate of I, 1 plus I is 1 minus I. It's just like, difference between two squares we take. So we have W is given as 2 over 1 plus I plus 5Z times divided by 2 plus I. Okay. What we need to do is, first of all, remove this term. So how do we do this? We multiply it by the conjugate of the denominator. So 1 plus I, the conjugate of this is 1 minus I. So you multiply, what you do is you get the minus, well, same thing, you get the minus value of the item. So you multiply both the denominator and the numerator by 1 minus I. 1 minus I. Yeah, like a bit. Plus 5Z times 2 plus I. Multiply both sides by 1 minus I. 2 minus I, 2, so 2 plus I, the conjugate is 2 minus I, multiplied by 2 minus I. Now, why do we multiply by that? You will see it in a minute. 2 into 1 minus I. What is the value here? 1 into 1, 1. So difference between two squares, right? So 1 square minus I square. What is minus I square? I square is minus 1. So minus 1 becomes 2. So you can cancel these two out. So that's why we sort of multiply by the conjugate and you get the more simple term. So you get 5Z times 2 minus I here. What do you get here? 2 square is 4 minus I square, that is minus 1. Minus 1 becomes 5. Okay, cancel 5 off. Right? So the answer is 1 minus I plus Z 2 minus I. Now the same thing W. Now we got in a more simpler form. Right? So last thing you need to do is, so we have been given that imaginary W is -1. Now what is the imaginary part of this? Now because Z is a complex number, is in the form x plus iy form. So we can't directly say what is the imaginary part of this and what is the real part of this. So but we can, for this we can say the imaginary part is what? Minus I, right? Coefficient of I is the coefficient of I is -1. So imaginary part of W can be written as imaginary part of W can be written as the imaginary part of this part and the imaginary part of this. Okay. So what is the imaginary part of this? The coefficient of I, that is -1, plus the imaginary part of this whole thing. Imaginary part of Z times 2 minus I. Right? So then what? We have been given the part of image. Why did I get imaginary W in the first place? Because they have given it. Imaginary W is given as -1. So we substitute that here. minus 1 is equal to minus 1 plus imaginary part of z 2 minus I. So minus 1 can be cancelled out. So we get imaginary part of z minus z times 2i 2 minus I is equal to 0. Now, again I said, what is a complex number is in the form x plus I y. So the y part is the imaginary part, x part is the real part. Now what happens when the y part is is 0? So here we got the imaginary part of this entire complex number is 0. That means y is 0. That means there's only a x term. That means only a real number. So we can just say that the z into 2 minus I, this complex number is not actually a complex number, but just a real number. We can just say it's lambda. So we can just, from this, we can identify that, okay, this is actually z into 2 minus I is a real number. So that's one part we can get it. So from the first part, they have given that imaginary w is minus 1. We got that part. So the next thing we have been given is w minus I plus 1 is equal to 5. The modulus value of that is equal to 5. So where can we apply this? So what is w? We already got it. This is w, and we simplified this as well. And we got that w is this. This is w, right? So what is w minus I, w minus 1 plus I? Let's see. So w minus I minus 1 plus I is equal to, this is w, right? So 1 minus I plus z times 2 minus I minus 1 plus I. So minus 1 cancels off. Minus I plus I cancels off. W minus 1 plus I is equal to z times 2 minus I. Now what they have given us is this whole thing, w minus 1 plus I minus 1 plus I, the modulus value of that is given as 5. Right? Yeah, it's given as 5. So what is w minus I is this. That means the modulus value of z into 2. What is z? This is just a real number, right? We got it before, lambda. Just put it as lambda is just as a constant. So we can say that lambda, the modulus value of lambda is equal to 5. Now, what do you mean by modulus? It's always the positive value, right? So if we have minus 5 and you get the modulus, it will become 5. So if you get 5 and get the modulus value, it will still be 5. So that means if you remove the modulus value, how do you remove it? Lambda can be written as plus or minus 5, right? So what I do is, like, anything the modulus value is given as 5, that means lambda is equal to either plus 5 or minus 5. Got it? What is lambda? We got it. This is lambda, right? Is it 2 minus I is equal to plus or minus 5. What is z? That is what I need to, like, we are doing all this to find z, right? Plus or minus 5, divide the whole thing by 2 minus I. But whenever you have this imaginary, like, complex part in the denominator, what you need to do is multiply both the denominator and the numerator by its conjugate. What is the conjugate here? 2 plus I. 2 plus I. We'll get plus or minus 5 times 2 plus I over, what is this thing? The difference between two squares. 2 square is 4 minus I square. So minus I square is how much? Minus 1. 4 minus minus 1 is 5. Cancel these two off. So what is the answer again? Plus or minus 2 plus I. What is that? Is it right? That's the answer we need. We need to prove that, show that z is equal to plus or minus I. Plus or minus 2 plus I. So did you get that part? even if you haven't done complex numbers, maybe a little bit probably understood. I'll just go over it one more time just to make it clear. So for the first part, we did an Argon diagram, right? In an Argon diagram is basically you represent the complex number in a diagram. That is, the x part represents the x coordinate, y part represents the y coordinate, imaginary and the complex number. And then what we did was we had two parts here. So we got the value of A, and then we got the value of B. And how did we get the value of A? Using that theorem I said, we got the midpoint of this, and then we multiplied by 2 to get the value of B. So, and then we had to guess the value of C. What is C? The parallel, if you complete the section, the parallelogram, C is this point. So we use the theorem that if you have two complex numbers and add them together, this is the point you get. So when you add the two complex number, we got the coordinate of C. So next question was, we need to find the complex number of, we need to use this two equation and find the complex number Z. So what we did for that was we got W, and first thing you did when you have something like a complex number is you remove the denominator. You remove the denominator by multiplied by the conjugate. When we simplified, we got this answer 1 minus I plus Z times 2 minus I. And then we have been given that the imaginary part of W is minus 1. So what we did is the imaginary part of this is minus 1. The imaginary part of this, we took at the whole thing. And when we simplify, we got that the imaginary part of this whole thing is 0. Now, if the imaginary part is not there, that means it's a constant value. So we just put it as lambda. And then in the next part, they have given us that W minus y, I minus 1 is equal to 5, the modulus value. So when you simplify it, you get the same thing here. We get the modulus value as 5. So lambda is equal to 5. So, sorry, the modulus value of lambda is equal to 5. If you remove the modulus, lambda is equal to plus or minus 5. By substituting that and simplifying, we got that Z is equal to plus or minus 2 plus I. So that actually brings us to the end of the first question, first three questions. So it's almost 12 o'clock, is it? Yeah, it's 12 o'clock. So I hope you guys learned maybe a little bit. And if you don't know, maybe you learned a little bit. So anything you want to say? Okay, no problem. Also, someone is asking about is there a lesson-wise covering for 2023? So I'm not sure about the lesson-wise lessons. Will it be conducted? Maybe it will be. I'm not very sure about that. So thank you all for joining and staying with us for so long. So I think that's it from me, and I'd like to hand it over back to the Majlis. Thank you, and over to you.
Thank you. We hope this session was indeed so productive. More educational webinars and motivational sessions will happen in future, which will surely support you in various ways. You can access our YouTube channel if you missed previous webinars. And please feel free to contact us if you want to leave any suggestions or comments based on these sessions. Stay connected with us for more updates. Once again, thank you for joining us and keep working hard to reach your goals. Muslim Majlis of University of Sri Jayawardhanapura genuinely wish all of you for a successful future. Stay safe and have a week ahead. Thank you.